Hey, today we are going to watch a video on stem and leaf plots and how to read them. All right, so one way to organize and display data is in a stem and leaf plot. So the example at the right represents the data of 31, 31, 43, 47, 61, 66, 68, and 70. Okay, so if I look here, I have 3 and the 1. That's where I get the 31. 4 and the 7 gives me 47. Okay, so my stem is going to be tens in this case. Sometimes that line can represent a decimal, but in this case, it's going to represent 10. The leaves represent ones. So my 3 is 30s, my 4 is 40s, my 5 is 50s, my 6 is 60s, 7 is 70s. Okay? All right, so think about how the plot is arranged and describe what you notice. So I just talked a lot about what you would notice with it. And for example, how would we add 42 to this plot? Okay, so if I were to add 42 in, it would go right there. Okay, one other thing that I should probably point out is notice that the 3 and the 7 right there in 43 and 47 is in numerical order. So the smallest numbers are always closest to the stem. The largest number is always farthest from the leaf, or farthest from the stem, excuse me. And then if you look there, what about 102? Okay, so if I wanted to put 102 there, I would have to continue on with 8, 9, and 10 in order to get to there. Okay, so then if I had my 10, I'd continue my line down, and 2 would go right there. Okay, any idea why you think the 5 is blank? Hopefully you said that because there were no choices or no data that represents the 50s, so 47 and 61, so I have that gap, so there's no data point there. All right, so now if you look at this example here, I have to make a stem and leaf plot. So in order to do that, I'm going to look at my data, and I'm going to see that my smallest number is 24. My largest number is 135. So underneath my stem, I would start with 2 and then just number all the way down. All the way down to 13. Okay, so then as I'm putting these in order, I have 24, so that's going to go right here under the leaf. Okay, and then I have 35, 44, 56, 57, 59, 59, 60, 60, 61, 61, 61, 61, 61, 61. Okay. All right, so obviously you can see I filled in the rest of it because I didn't think it was worth your time to sit and watch me write all the numbers, but all of the numbers in my stem and leaf plot should match up with the data that I have right over here. All right, now let's take a look at this example. So I have the stem and leaf plot has already been created. So I don't have to worry about doing that, but then I'm going to look at answering this question. It says, how many 20-year-olds are there? So remember, I have 0, 10, here's my 20. So I'm going to look right down here, and I count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 20-year-olds there, okay? So now if I want to figure out how many people are over 50, so then again, I'm going to look at my 5, which is going to be 50. And if I count 1, 2, 3, 4, 5, but then 60 is also older than 50. So I have 2 more, which is going to give me 7. All right, let's take a look at the last example. Hopefully you should have a better understanding of this, so pausing the video might help just for you to have some feedback on whether you're doing it correctly. So what is the mode? So if you remember what the mode is looking for the most. So I'm going to look over here at the number that is repeated the most. So I see I have 3/8, and I don't have any other number that is repeated. Okay, so when I look at the 3/8, there's a 3 in front of them. So what number is that? Yes, it is 38. Okay, and then how many data entries are in this stem and leaf plot? Okay, so this is one where I see it throws students off a lot. People think that they need to count the stem, and realistically, all they need to do is count the leaves. So if I count the leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There are 30 entries in this stem and leaf plot. Okay, so hopefully after watching this video, you have a better understanding of stem and leaf plots. Bye.